What is cold fusion reaction? Is it really just theory, or is it possible? Can it mimic conventional fusion or fission for, let's say, on a smaller scale? Okay. What is cold fusion? To understand what is cold fusion, let's first go into what is fusion. What is nuclear fusion? Nuclear fusion, conceptually, is when you take two atoms or nuclei of a certain element and you fuse them together. You take two nuclei, you fuse them together, or maybe you shoot them at each other at very high velocities. So high, the velocity should be so high that it overcomes the electrostatic repulsion of the nuclei, and these two nuclei collide, they merge together and they fuse together, and that gives off an enormous amount of energy. That, in brief, is what fusion is. Typically, you would do it with helium. He Helium fusion, hydrogen fusion, whatever, right? So that's what you do. Uh, so to do this, you have to overcome the electrostatic repulsion of the nuclei. A nucleus, in case you know, is a positively charged object. The nucleus of an atom has a positive charge. Around it, you have electrons going around which have a negative charge, and that balances out, and the atom is overall electrically neutral. Okay, so nuclei have a positive charge. Now, as you, I hope you know, like charges repel, opposite charges attract. So a positive charge is attracted towards a negative charge. But if you have two positive charges, they repel each other. The closer you bring them together, the more they repel each other. That's the repulsive force, the repulsive electrostatic force, right? So to bring two nuclei together, to bring them in contact, would require very high amounts of energy, which means that the two nuclei need to be shot at each other at very high speeds. So typically, what you would do is you create a state of matter called a plasma, which is a very high temperature and high velocity form of matter. And because the velocities of these atoms, these nuclei are so high, there would be collisions between them and they would fuse together, and that's how you get a fusion reaction. So the faster, the higher the velocity of a nucleus is, the hotter it is said to be. A gas is hot when its molecules are moving very fast at high velocities. A gas is cold when its molecules are moving at slow velocities. So a plasma in which you have nuclei that are moving at very high velocities is called a hot plasma. And if you have fusion that happens in this environment, it's hot fusion. So typically you would use something like a tokamak. What's a tokamak? Let me show you what it is. Tokamak is a device in which you could create a fusion reaction. It's a machine. So you use magnetic confinement to confine the plasma within the boundary of the tokamak. This is what it looks like. All right, so you use magnetic confinement to confine the plasma and ensure that it doesn't leak out of the walls of this machine. And hopefully you can have plasma that is energetic enough to have high velocity, high energy collisions, and you could possibly have fusion reactions through this. So that is the hope that we have, and that would be hot fusion at very high velocities and temperatures. What is cold fusion? It is a hypothetical form of fusion in which you can do this without going at high velocities and high temperatures. So let's say you have a glass of whatever it is on your tabletop, and if you can achieve fusion in that without heating it up, that is cold fusion. So in the past, some people have made claims that they have achieved cold fusion, but it's never been verified. They have never been able to prove it or demonstrate it. So those claims have turned out to be hoaxes, right? So that is the difference between hot fusion and cold fusion. Fusion is the holy grail. Fusion gives off way more energy than fission. And fission can be controlled in nuclear reactors. Hopefully in the future, we will have fusion reactors. Fusion is clean. There is no radioactive waste material that comes out of fusion. Fission reactions give off radioactive waste. You need to do something with that. You need to dispose of it in a manner that doesn't destroy the environment. It's dangerous. Fission reactions are dangerous. Fusion gives you much more energy and it's way cleaner. So that's why fusion is the future, but we should be able to achieve it. So as of today, there is absolutely no way in which we could achieve cold fusion. It's just a dream right now. Maybe in 100 years, maybe we may have technology, or we may have miniaturized tokamaks that are like you could actually hold in your hand. Possibly, who knows? But as of today, it's not possible. As of today, cold fusion is not possible. As of today, we have not even been able to create a sustained fusion reaction on our planet. So it's a work in progress, but hopefully it will happen sometime soon.